Greetings. In the past few days you have graphed points, and we've also talked about functions. We are going to here practice graphing linear functions from a function table. So I want to remind you of a few things before we get started. One thing is the word linear, you hopefully notice, has the word line in it. And so these should be straight lines. So you should be able to connect the points in your table when you make the dots on your coordinate planes. You should be able to connect them with a single straight line. If not, something or some things maybe have gone wrong. So just let you know, when you see linear function, should all be one continuous straight line. The other thing I want to point out that we should know now that's a little new to us is this notation that says f of x. And remember that that is just another way to symbolize the output of a function. And the output is the same thing as if it simply said y. So when I see these tables and it says x and then f of x, this is the y. So that as we fill in the table, then these will be x, y coordinates. So let's look at now, we're going to evaluate the function. We have evaluated before, so we just need to be plugging the number in for the x. So in this situation, we're going to take -3 and we're going to substitute it in for the x. So what that gives me, and you may want a piece of paper, some of you may feel very confident doing these mentally, some of you may want a piece of paper, some of you may just want a calculator, or both. I'll write a few of them out here to the side. This is what we're doing. 2 times -3 plus 1. So 2 times -3, that's -6, plus 1 is -5. Or I could have simply typed it in the calculator or ran through that arithmetic in my head. That -5, that's the output. That's going to go down here below -3. So when x is -3, y is -5. And then -3, -5 now become an ordered pair. -3 was the x, -5 is the y. So -3, so 3 to the left, down 5 for -5 for the y. So we would put a dot right about there. I'm making my dot a little messy, but so that you can obviously see it. Now we're going to repeat that process. We're going to use -2 for x. So right in there, we're going to use -2. So I'm going to have 2 times -2 plus 1. So the 2, again, is replacing the x. It's substituting in for the x. We know that when a number is written right next to a variable that it means multiply. So 2 times -2, -4, -4 plus 1 is -3. Fill it in on my table. Now -2 for x, -3 for y. And then I move on to the next one. And then maybe I start to see the pattern and I just say to myself, 2 times 0, that's 0, and 0 plus 1 is of course 1. And then my ordered pair would be 0, 1. All right, pause the video and come back and see if you got the same answers for when you use x is 1 and x is 2. You're back already? Did you pause the video and try it yourself? All right. And there are my final 5 points. And notice that if I have a steady enough hand, I can connect all of these points with a single straight line. If something happens that I can't connect them all with a straight line, if there's only one that's off the line, then I know which one is wrong. If it, is a hodgepodge, then I may have many things wrong. All right, I'm going to show you one more of these. We're going to do number 3 because the scale is different, and also because with the minus 8x, it tends to be one that gives people a little more trouble. So in the meantime, if you want to pause and try number 2, but I'm going to do number 3, and then you can check to see if you got the same thing, I guess. All right, before I start number 3, I want to point out that number 2 is actually just a little bit shorter. All you need to do is add 5 to each of those numbers, so it's just one step. So you might very easily be able to get those answers without writing things down, because all you have to do is negative 6 plus 5. So yeah, negative 1. You got it. And so on. All right, number 3. For number 3, notice that the center, we're not centered. Our x-axis on number 2 and number 3 are not centered. The x-axis is way down near the bottom. So it's going to be in different places depending on the problem. And in number 3, my y-axis is actually counting by 4s. So we might get some pretty large numbers for y. So don't be surprised by that. So again, we're replacing the x with whatever these numbers are. So we'll start with 3. So 4 subtract 8 times negative 3. We'll start with negative 3, that is. And then we know that order of operation says that the multiplication would happen first. So negative 8 times negative 3 makes positive 24, and 4 plus 24 is 28. Or you could simply type that into your calculator all at once, but it is 28. Then I'm going to do 4 minus 8 times negative 2. So then I have 4 plus 16, which is 20. Then I'm doing 4 minus 8 times negative 1. So I get 4 plus 8 is 12. Then I'm doing 4 minus 8 times 0. Remember, the multiplication happens first. So this is just 4 minus 0, which is just 4. And then 4 subtract 8 times 1 would be 4 minus 8. So this is negative 4. So negative 3, positive 28 is up here. Negative 2, positive 20, and so on. Remember that the one with 0 for the x will be on the y-axis. Right, so you should also plot the other 2 points. You will find that they do make a straight line. You have 9 problems on this page. I have assisted you with 2 of them. Your assignment is to complete the other problems on this side of the page, and then it is your choice. you may do the opposite side of the page for bonus points. So you choose how you want to spend your time. Some of you may have some other makeup work that would be a better use of your time. But that's a chance to pick up some bonus points with some extra practice. Okay, I hope that was helpful. You should have had this folder, this paper would have been right behind your domain, range, and is it a function notes.